Yeah, welcome back, guys. So let's continue where we left off. Now, I guess we left off. So we want to get the total RAM size programmatically, so we can do something about it, and just so that we can divide the total size by page, and we can will know how much we want to store and stuff like that. But to start with, we need to pass the DTD. And DTD is like the metadata that is stored, that has this kind of information, like how many CPUs, how much memory, stuff like that. So in QUMU, we have it stored in 4000 for this base address. So we created this structure with that base address, and we can swap the bytes, because it's big Indian, because ARM supports little Indian, but that's the structure is added as big Indian, I guess. So now we are trying to write the algorithm that is going to so this is the actual structure, and this DTD of struct, this address will have a lot of tokens. We have to parse those tokens to find slash memory, and that token will have the actual value that we need. So we need to write an parser for this. Okay, let's just write the parser, token parser in this. Okay, I gave R instead of this. Okay. I didn't understand. I mean, I understand the code, but I don't understand why we have this whole fucking thing. We read the token, we increment the size, and we switch based on the token. So we'll start with begin. Now we take that pointer and we check, is it memory? If it's not memory, until we reach /1, that's the null character, we just keep forwarding. Once we reach that, we once go forward, and then now we need to align P to 4 bytes. So until we Until this is 4 byte aligned, we keep pressing forward, and then we break. At this point, we should have been in this. We break out of it. Now we again read that pointer. We would have got a token, and that would be this token. Here we keep doing this step until we find a token that has reg as value. If we find that token, then we have found the node. We get the RAM there, we move past it, and we break. And once we have the end node, we set it to 0. Yeah, I just remembered why we need the total RAM, because so that we can allocate the bitmap as in let's say you have 500 MB RAM. In that case, you need to divide it by 4, because we are having 4 KB pages. So if we divide it by 4 KB pages, we'll get a value, and that value will be the total size of this bitmap. And every index within this static bitmap, will be a page, and we will also set a bit saying whether this page has been allocated or not. So this way we can keep track of the physical pages, and this is physical page, not the virtual page. Yeah, that's an important difference, because this morning when I was trying to do whatever I was doing, I assumed something wrong, and then I learned that we need to keep track of, there's no point in keeping track of the virtual memory, because the virtual memory is specific to process. There is we just keep track of the physical pages that we use, so that no matter who wants to use that physical page, we just know whether it's allocated or not. And also, to be specific, none of the process should have any idea about what physical page they have been assigned to. They just have to be sure that their page is allocated somewhere. That's all they care about. And that's the reason we are gonna write this parser ourselves. Wait. If we can move this to kmain, is it worth moving it to kmain? After initializing it, if we move it to kmain, no, if I have to move it after init, then I also need page tables for reaching out to this 4000. That will be not that interesting to implement, so let's just keep it here. But the issue is that if I keep it here, I won't be able to use uart, because my uart has a hard-coded address of that it will reach here. But this is a virtual base address which is mapped to 9000. So it's just one hell of pain to change everything. We'll just keep it as it is. We can use GDB to see if whatever we did is correct or wrong. And let's change this fucking thing first of all. we get a const void pointer, and we cast it to uint 8 pointer. But this is already a u8 pointer. Then why do we need this X step? I don't think we need it. We'll just we'll remove that. We'll just directly say we are going to get an static inline. We're going to send out uint 32. We're going taking a uint pointer, and it's already there. We'll simply use it. Can change it, or I can just change P to P. Now it would be perfect. Now we have a helper function that's just going to take a uint pointer, and it's going to swap the bits, so we will have proper alignment for ARM, because it will have a different alignment. It's a super simple operation. We are just shifting bits from their index to the opposite index, I would say. Yeah, this should be good. We don't copy the entire thing from here, because just LLMs just aren't that good. They'll just throw in random stuff, and the next time when you look at it, it'll be like puzzle. So it will be better if you write it, because you don't have to worry about debugging it later. So straight off we are just taking the values out of those things. And that is so this is a dynamic way of figuring out where things are. So from the base address we have offsets. The struct will be after this number, so it will be starting from this plus this offset value. And for the strings it's the same, it will be starting from this plus this offset value. That's why we are going to take both the offsets. We need offset of dd struct, and we need offset of dd string. If you could type fucking, and you get built-in. Why is my autocomplete not showing that fucking swap, whatever it is, header and of the strings? I believe this will actually contain the strings, and even every string is offsetted. So if this struct refers to a string in index 5, sorry, we just go to this base address, and we can take it off. So we need uint 8. Uint 8, I think this just refers to char pointer. I don't know. Let's just ask that question. Is uint 8 and char pointer same? Okay, char has minus 120 to, so I guess it is also the same. 127 into 2, it's 254. I guess it's the same thing. It's just that it has sign and it does not have sign. If not, it's the same thing, because we have 254. Even uint 8 is 254. That's why I was thinking maybe we could just write it as a char pointer, because I believe it's just going to have ASCII characters, because we are actually interpreting them. Okay, let's just keep it as uint 8 pointer and dt struct equal to, so now we have the base address dt base plus offset of struct. Now we have the second destruct strings, and that would be again the dd base plus of string. Okay, now what do we do? Now we have the base address for dd strings and dd struct, and we also have the base address. Now where do we start? We start from struct ptr. Why do we have to start from struct ptr? I guess that's the actual metadata, and that metadata is pointing to strings, because they can they don't want to have variable values. Okay, int 8 p is equal to dt struct. We don't need any index, because this will be the index. We are just going to keep moving that. Let's start by reading from p and move its index plus 4. That is now we have a token value. Yes, now we have a token value. We can switch that token, and we need to define the 3 possible token values. I think the four possible token values, it's begin node, end node, prop, nop, and end. Okay, let's define them. Node token node one begin is 0x2, it's 0x2, right? No, begin is 01, end is 02, prop nop. So there is no node. Okay, there's only begin. X2 token end. My fucking mind is not working. Define token prop, I guess. Is it prop? It's 0x3. And then we define token. What is that? Nop. It's 0x4. Define token. It's the final one. It's end. It's 0x5. Just to be sure, we need to check one thing. We'll just Google it once. QUMUDT structure. What do we actually call this? What is this? DTB. That's why I fucking can't even remember TTB. File metadata. Device tree metadata. And then I have to change it to DTB. I could have just copy pasted the fucking thing. That's fine. Parsing DTB. QEMU DTB. This is DTS. We are in DTP. Flattened device trees. Just another name of the same binary format. We have the header, memory reservation, and the structure block, and the string block. And see, the fucking thing just copied everything from this blog, I suppose. Yeah, I guess he wrote it in it's Rust. And yes, this is the way. We have 0x1, which is begin node, and the end node, and prop, and nop, and end is x9. Okay, fine. And it's 1, 2, 3, and a 4. Okay. He has written the entire thing into an actual parser because we don't need that. We only need the memory part. So we are going to stick with the static implementation where we just get into every node and check if it's memory. If it's memory, we do whatever we want to do. If not, we just continue to the next node because we don't care, because we only care about the memory node. But if we have to actually pass the entire DTD, maybe probably we also have to go with some algorithm like that that can actually go into every node and convert it into an object. So finally, when we can just go to every object and see what's present in that object, that would be a fully fledged DTB parser, but we don't need that. Let's just start with the cases. And the first case would be token begin. What do we do here? Can we actually put colon brackets? I don't know. I guess we can. I don't really know. We'll try. I guess we can. And now we can take the first node. Nodes is the node's first value string. Each token line before. What? Each token must be 4 bytes aligned. Okay. We read 4. That's the token. So we move forward 4 times. And okay, so that's PDF. And it's 60 pages. Fuck me. BDB node marks the beginning of the node description. Each node except the root node name of the node is stored in null terminated string after token. Okay, see, the name of the node is stored as null terminated string after FTT begin node token. In that case, if we were to put these things, wouldn't that cause an issue? We are actually trying to read from memory that may not be there. That's true. We can just write an edge case there. It's a super simple if condition. We could just say, let's first of all take the name. That would be p cat star p. Now I have to confirm whether name of 0 equal to, if it is this, we can say that we are not inside the memory. Where did he define those fucking stuff? Let's be memory efficient and we'll put this. And we zip past it. We add those as else if conditions. Come back to here and while star p not equal to we can put p plus plus, and then once we have reached it, we again get past that null termination. Now what do? Now we have to actually try to let's also write this part. Name 0 is equal to mem I guess even just comparing to is enough. Me, and we'll also maybe compare MEMORY. Then name of 5 equal to y. If it is this, then we are inside memory. Equal to 1 else. Else we set inside memory 0 and now if we are inside memory, maybe we can break. No, we have we went past the memory token. If we are inside memory, there is nothing else to do. We break. I guess that's it. And we can go to case, token, begin, token end, not token prop. What does those stuff do? Yeah, we also have to align it. Align that memory to 4 bytes because in case this check was a bit rusty, then we may need to align it. Well, uint 64 p 3, unless it's 1 we keep pressing forward. If it is inside memory, we break. No, we break either way. We only break. What's the fucking point of this variable? You fucking piece of chunk. What's the fucking point? Oh, okay, yeah, here. If we are inside an node, then, and if we are inside the prop, then we can consider the property, whether the property is registry or not. Inside memory, the property is reg. Okay. Makes sense, makes sense. So, but if we are inside the memory, because that's not needed, because no matter what, we have to break. Because let's say some other token was here, even then we have to break. We are not supposed to go back to the next case. We only go to next case through this, because as soon as we break out of this, we come back in the for loop and we again read the p-value, and that token has to be a token prop. In that case, it can reach that part of code. Okay, I get it. Now let's see what else we have to do. Now we have to now we have to read the length. Now we have to read the name of is the okay. So in this part, inside the inside this prop tag, we have length. That is the length of the string, I suppose. and name of is the offset within that strings, because we have this strings pointer. Within that we have offsets, and if you want to read this particular string, you have to go to that offsets. I guess I have seen this somewhere. It's in task struct. Yes, I guess task struct also follows this format. Wait. Let's ask this. Task struct also follows this kind of offset based indexing to get strings. No? Then where did I see that? I remember somewhere I've seen this kind of no, somewhere I've seen this kind of structure in Linux. Do you have any examples of other? What the fuck? Using this kind of format to index into strings. I don't know. Maybe BPF or initram. Maybe it's in initram, because I have worked with initram and BPF. I have never worked with performant events or DARF or ELF. I mean, I know ELF, but still I don't think I have ever parsed it, tried to parse it. Okay. Still. Okay. The sidetracked. Let's just go back to our parsing and finish off this tag. And now we have to read the length. And read the name of the offset within the string. So let's read the length. What's the type of length? It will be u into 32 length, and it will be, we can read it off like read b32 p, and we can increment p by 4, and then we can read it 32 offset, string string offset and put read b32. Again, we can read the p-value, and we can offset increment it. U and T. Okay. Now we have the length, and now we have the offset. And so we can actually take the string. It will be a char pointer. No, it's not a char pointer. Let's put it as U int 32 pointer. Actual string will be we have to use D strings. I think it's D strings because that's where it is supposed to be. I guess it is uint, right? Okay. And string offset. And we can check if the string 0, let's say, equals R, and string 1, let's say it should be E, and put string and it's string 2 equal to reg. I don't know why I put 3 instead of g. In case this is equal, in case if this is equal, you can remove this. If this is equal, then we have found the value, and we can put to do parse size. If we haven't found this particular string, what are we supposed to do? Probably we could just zip past. I think we have already incremented past that, so I think we should be able to just break, because only if we have something we pass it. If not, we can break it, because in the next loop we should be able to read it back again. Read it back again in here. And yes, nothing much. That should do the trick. Yeah, let's see. Yep, we have to use the string pointer plus the offset, and you've used it as char pointer, we used it as int pointer. It is string, maybe it's ASCII string, so it's better to just use it as char pointer instead of uint. And the value is supposed to be in P. Okay, we are reading the value here. Interesting. So this is in the other structure, but the actual value is present here, because maybe the value is just uint 32. That's why they were able to keep this, and we are reading it like this because it's what's Little Indian, and our architecture is Little Indian, and the value is in Big Indian. That's why we are doing this extra nonsense. But maybe Hmm. And also we have to check if we are inside the memory node. If not, there's no point. So if we are inside the memory node and we check for RNG. Okay, that's good. That's good. And we just realized it that the actual value, we can put it as char pointer, and the actual value, the actual value is just the int uint32, but because we need those segments separated, we cast it as uint 8 pointer. And we can sometimes it's a bit hard to use the keyboard. Maybe I should switch to VI. I know the VS Code supports VI formats. I can do that, but that's for some other day. Now let's read the value. We have it here. What does this helper do? And we convert it into a U32. Instead, we change this and then we finally parse the upper part. We first convert it. I don't know. First of all, I don't fucking understand this part. Let's ask it to explain this. Or we could just see what exactly do we where's the prop is then followed by two 32-bit values. So the FTT prop token is followed by two 32-bit values. The name offset is the offset within the string, and the length of the property value. Length of the properties value. Okay. The name offset is the offset null string that contains a string block. Okay. Value of the property for and again padded with until the next description is somewhat vary and it might be hard to figure out what's going on. Just I need to understand what can we do after we reach the No, I don't get it. I don't see exactly where he has parsed the. Ah, okay, here it is parse nodes. If it's a token, if it's equal to finish. Mm, mm, Begin. Now we write the prop. Here we have the length. So that's the first 32 bits. And then we have the next 32 bits, that's the offset within the string, and then we have to consume data up to the length. Okay, so now we just read up to the length. Okay, so what we have to do here is um, we have to start from p until this length, and he has directly consumed it because he wants to pass every token properly. We only care about it if the string is reg. Then we write the for loop. Let's say it starts with int I 0 less than or less than length I plus plus, and here we can write we get every bytes because we are moving forward 8 bytes. I guess it's 4 bytes at a time. 4 bytes at a time. So what we can do is we move forward 4 bytes at a time, and what the fuck. I'm not able to picture the fucking thing. We have the string. No, we have a pointer and it has a length. Like, what exactly will be in that? That's what I want to understand. What is this value? What is this value? If he had just given the annotation here, life would have been so much better. Okay, let's see what the chat GPTs. Here we divide length by 16 and we go through it. Did he do anything like that? He has taken next 32 bits and we just directly consume data till that length. I believe it's going to be a 32 bit, so it's a uint value. So why do we have to say divide it by 16? we okay, we convert it into a U16. That's why we are changing the higher, I mean, like we are shifting the higher address to start from 32 bit, and we are keeping the lower address here. Okay, that's fine. So what's the point? What's the fucking point? Why did we even parse this base value? No, 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 no. This base value is just waste of time and fucking energy. Hmm. So, I mean, like, I understand this fucking code. We have taken the higher address, we have taken the lower address, and we are shifting it to the higher address of the 16-bit value and keep the lower, and we convert it into a single U62 64-bit base. 32 divided by 16 is 2. And length won't be 32. Length will be probably... I think this is a fucking overkill. We don't have to do any of this. Just waste CPU cycles. We have the length and we have this value. What is the actual format we are expecting there? Shouldn't it be just another 32-bit value? Then why do we have a length if it were just 32-bit value? You fucking moron, did I ask you? Register. Properties always size cell. Meaning 62-bit addresses encoded as two 32-bit big Indian cells. But why? Whoever taught LLMs to use emojis, you fucking sicko. Whatever. Yeah, we did make some progress and it looks good. We have passed and we have come till this. Let's do that.